Hey friends, my name is C and you're watching MakesItEasy, and welcome to a new video for IGCSE at Maths. And today we have a new questions video for differentiation, and the link to this PDF from DrFrostMaths is in the description or in my website, so you can check it out in the description. And before you get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And we'll move on to question 1. A curve has a gradient function of dy over dx equals 2x squared minus 7. Work out the gradient of the curve when x equals minus 3. So we already have the gradient function right here, so we just have to substitute x by minus 3. So dy over dx equals 2x squared minus 7. And this sign right here, x equals minus 3, just means the condition where x is minus 3, which means it will be 2 minus 3 squared minus 7 squared. So minus 3 squared is 9, 9 times 2 is 18, and 18 minus 7 is 11. So the gradient at x equals minus 3 will be 11. And that's the answer. And question 2, a curve has a gradient function of dy over dx equals 2x squared minus 7. Work out the values of x for which the rate of change of y with respect to x is 1. So this right here, it looks a bit confusing with the rate of change of y with respect to x, but it basically means the gradient function. Because whenever you have a gradient function like this, you will call it the rate of change of this right here with respect to this value right here. So dy over dx, it has to be equal to 1. So you do 2x squared minus 7 equals 1. You just rearrange it to solve for x, which gets us 2x squared equals 8. X squared equals 4. Divide both sides by square root both sides to get x equals plus or minus 2. Because you get two answers, because if you square minus 2, you get 4. And if you square 2, you get 4 as well. So the value of x could be x equals plus minus 2. Like so. And question 3. A curve has equation y equals x cubed minus 9x squared plus 24x minus 16. Work out dy over dx. So it's basically just differentiating. So dy over dx will be equal to the first term for the x cubed term, pull the power down, and 3, x then the power minus 1, 3x squared, minus the second term, the power pull down and times by the coefficient, minus 18x. And the third term will be just 24 because the x to the power 1 just becomes x to the power 0, which is just 1. So plus 24. And that's the answer. Dy over dx equals 3x squared minus 18x plus 24. And question 4. Work out dy over dx given this equation right here. So what I would do is that I will first expand the equation. So this is just y equals x to the power 1 over 2 times x to the power 7 over 2 minus x to the power 1 over 2. So to times the first term, you get 1 over 2 plus 7 over 2 because that's one of the indices rule, which is equal to 8 over 2 or 4, minus 1 over 2 plus 1 over 2 will be 1, so it's just be x, right? So to differentiate this, dy over dx, you get the first term, you pull the power down and the power minus 1, 4x to the power 3, minus x just becomes 1, so it'll be 4x cubed minus 1. So dy over dx equals 4x cubed minus 1. And question 5, work out dy over dx given this equation. So we can actually just spot like a little trick, because we can factorize the x because not all of the x are factorized. So it'll be y equals 3x cubed to 3x squared 2x cubed minus 5 over x squared. So we can cancel out the x squared, and then you will get, you will get 3 2x cubed minus 5, and if you expand it, it will be 6x cubed minus 15. And if you differentiate this dy over dx, you will get 6 times 3, which is 18, and power minus 1, 18x squared. And that's the answer, so dy over dx will be equal to 18x squared. And question 6, a curve has equation y equals x squared x minus 2. Work out the gradient of the curve at the point 3, 9. So we first have to differentiate this, and I could just expand the bracket first, so it's much easier. So it'll be y equals x cubed minus 2x squared. So if I differentiate this dy over dx, it will be 3x squared minus 4x, like so. So we have to find a gradient at x equals 3. So this right here, x equals 3, will be equal to 3 squared minus 4, 3. And if you expand everything out, like 3 times 3 to the power 2 minus 4 times 3, you will get the gradient function, or the gradient, equals 15. So that's the answer. So the gradient dy over dx equals 15. And question 7, for the curve y equals f of x, we have this right here. So work out where k is a constant. When x equals minus 2, the gradient of the curve is 12. So work out the value of k. So we already given the gradient function right here, dy over dx, and the gradient is 12 when x equals minus 2. So we can substitute some values. So it'd be 12 equals 3 over 2 times minus 2 minus k minus 2 to the power 4 plus k. So this will simplify to 12 equals, this 2 will cancel out, so it will become minus 3 minus k times minus 2 to the power 4 will be minus 2 times minus 2 times minus 2 times minus 2, which is 16, plus k. So you get 15 equals minus 16k. This will be minus 16k plus k, which is minus 15k. Therefore, if you divide both sides by minus 15, you get k equals minus 1, like so. So k equals minus 1. So question 8, the curve intersects the x-axis at P and Q. Find the gradients of the tangents to the curve at P and Q. So we have this factored form right here. So we know the roots are x equals 2 and x equals 3. So, and the x equals 2 will be point P, and x equals 3 will be point Q. So we can also expand this one right here, this y equals equation right here. So it'll be y equals x squared minus 5x plus 6. And so dy over dx will be 2x minus 5. So we have to take into account of x equals 2 and x equals 3. So the gradient when it's p will be 2 times 2 minus 5. It will be minus 1. And the gradient where it's q will be 2 times 3 minus 5 will be 1. So these two are the answers. So the gradient at P will be minus 1, and the gradient at Q will be 1. Oops, like so. In question 9, write down the equation of the tangent to the curve at A. So you can notice that A and B are both stationary points, which means that they have a gradient of 0. dy over dx equals 0. So they will have no gradient. So the equation of the tangent is basically the one that's like this. And you can notice that A lies on minus 2, minus 3. And the y value is minus 3. That means the tangent to the curve at A must be y equals minus 3. Which is quite straightforward. So the answer is y equals minus 3. So y equals minus 3. So let me just rewrite this. Y equals minus 3, like so. And question 10, there's a maximum point at A is at 210. Write down the equation of the normal to the curve given at A. So maximum point is the same as stationary point, which have a gradient of 0. So we know that this is the tangent, which would be y equals 10, because this right here is 10. So this right here will be the normal, because the normal is always 90 degrees to the tangent. So we know that this point right here is, the A is 210. That means this must be 2. So this line must be x equals 2. Like so the line must be x equals 2. So the number to the curve is x equals 2. So question 11, find the equation of the normal to the curve at A. So right here we have A. So we can notice that A lies on the y-axis, which is when x equals 0. So we have to find the y value, which is just 0 plus 1, 2 minus 0. So 1 times 2, which is just 2. So the point A is 0, 2. And we can also expand the bracket for y. So y equals x plus 1, 2 minus x. So it will be 2x minus x squared plus 2 minus x, which gets us minus x squared plus x plus 2. And we have to differentiate it. So it will be dy over dx equals minus 2x plus 1. So we know that this gradient function, when we put the x value, we will find the gradient for the tangent, the negative reciprocal to find the normal. So we have to find when x equals 0, which is just 1. That means that the gradient for the tangent of the curve at A will be 1. To become the normal gradient, you have the negative reciprocal, which is equal to minus 1. So it will be y equals minus x plus c, where x is equal to 0 and y is equal to 2. So it will be 2 plus c. That means the final answer is y equals minus x plus 2. So y equals minus x plus 2, and that's the answer. And question 12. Work out the equation of the normal to the curve at like y equals x squared plus 4x plus 5 at the point where x equals minus 3. So let's just find the corresponding y value first. So y equals, you just substitute the value for x into the equation. So minus 3 squared plus 4 minus 3 plus 5. That will get you, let's use the calculator, 9 minus 12 plus 5, which is 2, y equals 2. So we have to differentiate the function first. So dy over dx will be equal to 2x plus 4. At the point where x equals minus 3, the tangent gradient will be minus 6 plus 4 minus 2. So to find the gradient for the normal, you have to negative reciprocal it. So the new gradient will be 1 over 2. So then it will be y equals 1 over 2x plus c, where we have to put the value for x equals minus 3 and y equals 2 to find the corresponding y-intercept. So it will be 2 equals minus 3 over 2 plus c, and therefore, c equals 2 plus 3 over 2, which is just 7 over 2. So, therefore the final answer will be y equals 1 over 2, as seen just now, 1 over 2x plus 7 over 2. And that's the answer. In question 13, the curve y equals 2x cubed minus 5 intersects the y-axis at C. The tangent of the curve blah 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 intersects the y-axis at D, and so on. Work out the length of CD. So to work out the coordinates for C, it will be quite straightforward. So we have y equals 2x cubed minus 5. C is when x equals 0. So this will just cancel out. So y equals minus 5. So C is 0 minus 5, number 1. So we have to differentiate the curve, we have to find the gradient for the curve, find the gradient at the point where x equals 2, because that's the tangent. So the curve will be y equals 2x cubed minus 5, and therefore dy over dx will be 6x squared. And where x equals 2 will be 24, because 2 squared is 4, and 4 times 6 is 24. So we have another equation right here. So y equals 24x plus c, where x is 2 and y is 11 to find the c value. So it'll be 11 equals 48 plus c. And therefore you minus both sides to become 11 minus 48. You get minus 37. So minus 37 equals c. So y equals 24x minus 37. Put when x equals 0 because that's where D is. Therefore y equals minus 37. So the point D is 0 minus 37. Like so. So now we have, let me just work this out right here. So we have C is this and D is this. So to get from minus 5 all the way down to minus 37, you will just do minus 37 minus 5, minus 5 minus minus 37. So minus 5 minus minus 37. That will get you a value of, minus 5 minus minus 37. The value of 32. That means the distance between C and D is 32 units. So CD equals 32 units. Then question 14, work out the stationary points on the curve y equals x cubed minus 12x. So just differentiate it with dy over dx equals 3x cubed. And that's it, because, there is something, 3x cubed minus 12. So set that equal to 0 to find the stationary point. So 3x squared minus 12 equals 0. Rearrange the equation to get x the subject. So x squared equals 4. And therefore x equals plus or minus 2. And we have to find the corresponding y value. So up here, y equals x cubed minus 12x, while x is 2, will be equal to 2 cubed minus 12 times 2. So 2 cubed minus 12 times 2, which is minus 16. So when x is 2, y is minus 16. And when x equals minus 2, it will obviously have the slope sign, which is 16. So these two are the stationary points. So 2 minus 16, and minus 2, and 16. And these are the answers. And question 15. A curve has equation y equals 4x cubed plus 6x squared plus 3x plus 5. Work out the coordinates of any stationary point on this curve and determine the nature. So we actually haven't come across determine the nature, and I'll talk about this in the next lesson, but I'll just go through it slightly. So let's just differentiate the curve first. So dy over dx will be 12x squared plus 12x plus 3. So equals 0. So we'll just factorize this equation. You get 4x squared plus 4x plus 1 equals 0. And if you put this into the quadratic equation, you get a value of x equals minus 1 over 2. Just one value, because it is a repeated root. So think of it this way. You have a repeated root in a gradient function. So just think of it first. So the corresponding y value will be y equals 4.5. So the stationary point will be minus 1 over 2 or minus 0.5 and 4.5. Like so. And because we have a repeated root in the gradient function, this means that this point right here is a point of inflection. So an example for point of inflection is when you have a cubic graph, when inside this point right here is in a point of inflection because all of the points touch one point. All of the roots touch one point. So that is the point of inflection, and that's what describing this point right here. So the stationary point is minus 0.5, 4.5, and it is a point of inflection, like so. And question 16, the diagram shows a sketch of the cubic curve y equals 1 over 3x cubed minus x squared minus 3x plus k, where k is a constant, and the x-axis is a tangent to the curve at its minimum point. Work out the value of k. So we know that this right here, that is a minimum point, and this is a maximum point. So let's just differentiate the function first. Y equals 1 over 3 x cubed minus x squared minus 3x plus k. Differentiate to become dy over dx equals x cubed minus 2x minus 3 right here. So we can factorize this equation to get x, let me see, let me use my calculator, y equals minus 2, and then you will get x minus 3 times by x plus 1, like so, equals 0. And then you factorize to get x equals 3 and x equals minus 1. So now that this point here is 3, and this point is minus 1. So once you have this point here, which is 3, you can get the corresponding y value, which is just putting into the original equation, y equals something. But we know that this point right here, the y will be equal to 0 because it's on the x-axis, so the y is 0. So we can use this coordinate right here to find the value for k. So this equation will be y equals 1 over 3 x cubed minus x squared minus 3x plus k. Substitute y equals 0 and x equals 3. We'll read this like so. Minus 3 squared minus 3 times 3 plus k. So if you if you simplify this, you get 0 equals minus 9 plus k. And therefore you plus both sides by 9. Therefore k equals 9, like so. So k equals 9. So next we have question 17. A sketch of y equals f of x where this is a cubic function. The maximum point is 210, the equation of the curve blah blah blah, where p and r are constant. And use the maximum point to find p and r. So let's just differentiate the function first. So y equals px cubed minus 3x squared plus 8x plus r. So dy over dx will be 3px cubed minus 6x plus 8. So we know that when x is 2, it's a maximum point. So it would be 0 equals 3p, x equals 2, 2 squared, minus 6, 2, plus 8. You just simplify this to become, let's just use the calculator, minus 6 times 2, which is just 12, plus 8 will be equal to minus 4, so it will be 4 equals 2 squared will be 4 times 3 for p, which is 12p. Therefore, you just divide both sides by 12, so p equals 4 over 12, or 1 over 3. Like so. So when you have p equals 1 over 3, you can use the value, the coordinates, and the p to find r. So you have y equals 1 over 3 x cubed minus 3x squared plus 8x plus r. And we know that there's a point on the curve which is 210. So set when x equals 2 and y equals 10, like so. So it will be 10 equals a third 2 cubed minus 3 2 squared plus 8 2 plus r, and you should get a value of 10 equals, let me just put into my calculator, 1 over 3 times 2 cubed minus 3 times 2 squared plus 2 times r, which is 20 over 3 plus r. So it equals 20 over 3 plus r, and you minus both sides by 20 over 3. Therefore, 10 equals minus 10 equals 10 minus 20 over 3 to become r, and therefore r equals 10 over 3. And you have p and r. So let's just write it down. P equals 1 over 3 and r equals 10 over 3, like so. In question 18, which of these is correct? So we have p is a maximum point, and when x equals a, and q is a stationary point when x equals b. So we know that these 2 points are on y equals f of x, and a is smaller than b, and a is a maximum point. So you would naturally think that, it'll be like a downward graph, right? Because a is a maximum point, I'll just draw it like a line, but it'll be like a curve. So a is a maximum point, and after a, it'll go down because b is like beyond a. So let's say b is here, right? So we know that after, let's just look at some of the responses. So number 1, a, right? When a is less than x, less than b, the dy over dx is positive. And we know that this is not the case because you can see the gradient is clearly decreasing. So we'll shortlist to C and D. So they're both negative. So we'll look at the second response. When x is bigger than b, dy over dx is positive or negative. Let's just have a look. So this right here, and it's clearly a negative 2, right? So the answer is just D. So the answer correct is this new color, D, like so. Then question 19. The curve y equals x cubed plus bs plus c has a stationary point at minus 220. Look at the value of b and c. So I can just differentiate the function first. So dy over dx equals 3x cubed plus b. So it's a stationary point, so the gradient equals 0. And x value equals minus 2. So it'll be 3 minus 2 squared plus b equals 0. And therefore b equals 3 times minus 2 squared is 3 times minus 2 squared will be 12. So b equals minus 12, like so. So now we have y equals x cubed minus 12x plus c. We can input the values of x and y right here to find c. So x equals minus 2, y equals 20. So it'll be 20 equals minus 2 cubed minus 12 minus 2 plus c. So it'll be 20 minus, that's minus 2 cubed minus 12 times minus 2. It'll be 16 plus c. And therefore c equals 4. So we have to find the answer of b equals minus 12 and c equals 4. And these are the answers. In question 20, for what values of y equals 150x minus 2x cubed is an increasing function? So we know that this is a negative cubic graph. So it looks something like, it looks something like this, like so. It's always decreasing except for this part right here. And this part is actually between the two maximum and the minimum point, like the local ones. So between this right here and this point, it'll be an increasing function. And these two are the stationary points. So let's just differentiate to find the stationary point. So y equals 150x minus 2x cubed. dy over dx will be 150 minus 6x squared. So rearrange the equation to get x a subject. So 6x squared equals 150. X squared equals 25. Square root both sides, so become x equals plus or minus 5. So we know that this must be minus 5 and this must be 5. So between x equals minus 5 and x equals 5, the function is increasing because the gradient is increasing. So therefore the answer is just simply minus 5 smaller than x smaller than 5, like so. And lastly, 21, we have y equals 10 minus 8x minus x cubed for all values of x. Show that y is a decreasing function for all values of x. So let's just differentiate the function first. dy over dx will be minus 8 minus 3x squared. So now we need to use some explanation. So new color. So we know that for all values of x, we have x squared or x squared. It will be bigger than or equal to 0 because it's a square for all x value. And we know that it's multiplied by minus 3. That means that it will always be a negative number because a negative number times a positive number will always be a negative. So therefore we know that dy over dx will be less than minus 8, which is less than 0 for all x. And these are the answers. And that's it for this questions video for differentiation. And I hope you all find it useful and helpful. And if you did, please leave a like and subscribe and ring the notification bell so you don't miss out on any future videos. And if you have any feedbacks or constructive comments about my channel, my YouTube, or my website, or my anything, you can drop them off in the comment section and I'll reply to them. And check out my social media in the description for more daily contents, for example LinkedIn, or YouTube, or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you all find it useful and helpful, and I'll see you all in the next video, which will be rules and examples for rates of change. But until then, stay safe and happy learning.